Hey guys, my name is Aayush and I work as a DevRel at Nethermind, and I'm going to tell you about the Nethermind bounty which we have for ETHOnline 2024, and also tell you about Starknet and why Starknet is a game changer in the blockchain space and why you should explore it being in Web3. To understand why Starknet is exciting, let us first examine Ethereum's core scaling challenges. So that would be like the block size, time constraint. So with a 12-second block time and gas limit, there's a cap on how many transactions that can be processed on chain. Then comes the state growth. As more transactions modify Ethereum's global state, it becomes increasingly resource intensive for nodes to manage. Then comes the consensus overhead. In Ethereum, all full nodes must process every transaction to reach an agreement. This universal validation requirement fundamentally limits the scalability for L1. Then comes the data availability costs. Storing all transaction data on chain is really expensive, and this leads to rapid chain growth. These factors together combine to create a network congestion and high gas fees on L1, especially during peak usage of the network. This is where layer 2 solutions like Starknet come into the picture. They address these challenges in four key ways. First is increased throughput. Layer 2s process more transactions per second by moving operations off chain. Second is reduced cost. They lower fees of the transactions by batching multiple transactions into one L1 interaction. Third comes the maintained security. Layer 2s inherit Ethereum's security through cryptographic proof generation, which in case of Starknet is specifically called a validity proof. Finally, and perhaps the most exciting one, is that they enable us to do complex computation on chain. This means we can now run resource intensive operations cheaply, opening up entirely new blockchain use cases, which still needs to be explored. So Starknet as a ZK rollup takes these benefits even further. ZK stands for zero knowledge, a cryptographic method that allows one party to prove another that a statement is true without revealing any information beyond the validity of the statement itself. In Starknet's case, this means that we can prove that a batch of transactions is valid without processing each transaction individually on Ethereum. This achieves greater scalability while maintaining security, enabling a new class of blockchain applications which were previously infeasible due to cost or computational constraints on Ethereum. So Starknet brings ZK rollups to life using Starks, which is scalable transparent argument of knowledge. Here's how it works actually. So Starknet represents its entire state using a Merkle-Patricia tree, processing transactions off-chain to update this state. It then generates a Stark proof, a cryptographic guarantee that these updates are valid. This proof, along with the compact state commitment, is sent to Ethereum for verification. The beauty of this system is its efficiency. A single proof can validate thousands of transactions, which dramatically reduces the data footprint on Ethereum. This allows Starknet to achieve throughput and lower cost while inheriting Ethereum's robust security features. By moving complex computations off-chain but anchoring the results on Ethereum, Starknet opens up a new possibility for blockchain applications. It's not just about scaling existing use cases which are present on different layers already, but it's about enabling entirely new ones that were previously impractical due to cost or performance constraints. Now let us dig a little bit more on how Starknet is classified. So Starknet is classified as a type 4 ZK-EVM. It means it's optimized for efficiency rather than exact Ethereum equivalence. It's like we are reimagining what's possible with blockchain computation. This approach was crucial for scaling Ethereum because it allows for greater optimization and efficiency. By moving away from the strict EVM equivalence, Starknet can leverage custom built systems that are specifically designed for generating zero knowledge proofs. The trade-off is slightly different developer experience compared to how you do things on Ethereum. However, this sacrifice in immediate familiarity enables us to push boundaries of what's possible on the blockchain. We can perform more complex computation, handle larger data sets, and create more sophisticated smart contracts in Cairo, which is the programming language for Starknet, smart contracts, all while maintaining the security guarantees of Ethereum. And this is why Type 4 is so exciting. It's not about making Ethereum faster or cheaper, but about fundamentally expanding the capabilities of blockchain technology. Let me quickly walk you through Starknet's transaction lifecycle. It's a bit technical, but understanding this process is key to appreciating Starknet's efficiency. So the first step is transaction submission. A transaction is sent to a gateway, entering the mempool with a received status. The mempool is like a waiting room for transactions, holding them until they are ready to being processed. Then comes the mempool validation step. The mempool performs initial checks like ensuring sufficient balance for fees. This is similar to Ethereum's signature checking, but Starknet adds custom validation functions for different transaction types. Then comes the step 3, which is sequencer validation. The sequencer revalidates transactions before execution, ensuring they are still valid in the current state. The fourth step is execution. Valid transactions are applied to the state, failed transactions are included as reverted. The next step would be proof generation and verification. This is where Starknet's magic happen. The prover generates a cryptographic proof for the entire block's execution, which is then verified on Ethereum L1. This process allows Starknet to batch thousands of transactions into a single proof, significantly reducing costs and increasing throughput while maintaining Ethereum's security. It is this efficient proof system that enables more complex computations possible on Starknet. One of Starknet's unique feature is its built-in account abstraction. Unlike Ethereum's EOAs, which are externally owned accounts, all accounts on Starknet are smart contracts. This enables signature abstraction, which means that you can customize how your account validates transactions. Then potential for fee abstraction, which means that we can pay gas fees in different ERC20 tokens. Then comes nonce abstraction, which helps us to send multiple transactions in parallel. So this account abstraction built-in feature in Starknet opens up possibilities for various applications like social recovery wallets or biometrically authenticated wallets for your DApp. So Starknet uses a programming language called Cairo. Now the question comes, why do we have to learn Cairo? Why a different language? So let me introduce you to the features of Cairo. It's a language which is designed specifically for creating efficient ZK proofs, which is the key to Starknet's performance. Cairo allows developers to write complex logic that can be efficiently proven, enabling complex computation that were previously infeasible on-chain. You can do all these things just by writing smart contracts in Cairo. You don't have to create any more circuits or anything like that for creating ZK proofs. Now, if we talk about how you can dive in and start learning, we have got a range of resources to suit different learning styles and experience level. First, there's an official Starknet documentation. It is your go-to place for up-to-date guides and references for anything related to Starknet. It can help you start by setting up your environment, then declaring your smart contracts, creating an account, deploying your smart contracts, and then also interacting with them. You can deep dive into the architecture section to understand how Starknet works from an architectural point of view. For our deep dive into Cairo itself, you can use the Cairo book. It's a comprehensive guide that takes you through the language step by step to create provable programs on Starknet as smart contracts, or even a standalone provable program is possible to be written in Cairo. So this would be the go-to place to learn Cairo from very basics. For people who actually like the hands-on approach for learning any language, I would suggest using Starklinks, where you can understand how smart contracts work on Starknet by going through all these exercises and compiling them, and also seeing if things work the way you think they are working. Other than that, we also have Cairo on Exorcism, which can help you learn Cairo. For those who enjoy a more gamified experience for learning anything, Node Guardians would be the best place because they provide challenges and quests to level up your Starknet skills. We also have a crash course on Starknet, which is a list of various resources that you would use during your application building on Starknet. So I would walk you through all the resources that I mentioned here. First would be the OpenRPC playground. This would help you understand what are different methods that you can call from a Starknet node API. For example, like the Starknet spec version, which returns the version of the Starknet JSON RPC specification which is being used. Now the question comes, how do you create these code snippets. If that is also something which you want from us, then you can go on to the crash course page and then migrate to the Starknet JSON RPC builder. This is where you can request for code snippets for interaction to Starknet using Starknet.js or Starknet.go or Starknet.rs. For example, I'll walk you through a request which we can create here. To get started here, I would need an API key that I can get from Voyager, which is the blockchain explorer for Starknet. Now we can go to access Starknet RPC, get started for free, and here you need to create your own RPC API key. I'll name it as demo. Then we can copy this API key and go back to the JSON RPC builder, this one, and paste the API key here. Now I want to call this particular function Starknet spec version, and I can just click on send request. You can see I get a response here saying that the spec version right now is 0.7.1. You can copy code snippets from here if you're using Starknet.js. If you're using Starknet.go, you can migrate here. You will get all the code snippets which are required for creating applications on Starknet. In the crash course, you can also see that we have an introduction to Juno, which is basically a Go implementation of a Starknet full node client, which is created by Nethermind. This would allow node operators to easily and reliably support the network. You can create your own Juno instance on a system, and you can use that for putting the RPC requests that you are creating in this JSON RPC builder. Apart from that, these are the things which you can also use, like the Starknet CLI, then Starknet architecture documentation, which is also present in the Starknet documentation, then the Cairo book, and this is the bridge that you can use for Ethereum to Starknet. So basically this bridge helps you migrate your assets from Ethereum L1 to Starknet within 3 minutes, but a migration from Starknet to Ethereum L1 can take a maximum up to 7 hours. Then here are some links to the major dApps documentation which are present on Starknet. Ikubo is the largest AMM present on Starknet right now, and largest transaction router is Avenue. So you can use these dApp documentations to build something on top of them as well. Then here's the link for the Starknet ecosystem. You can go to this to explore all other community driven resources that are present for Starknet. Whether you are a beginner or an experienced dev looking to expand your blockchain skills, all these resources will help you get up to speed with Starknet and Cairo. We have plenty of resources apart from these which are driven by community as well. But to get the link of all these resources, you can scan this QR code. Now here comes the most awaited part, the discussion about the Starknet.anything bounty. We are offering a prize pool of $1,000 for the most innovative project that can be built on Starknet. So Starknet's architecture allows for some interesting capabilities that weren't feasible before on-chain. So we have some ideas of what you could build around. So things like DeFi, AI, verifiable compute, privacy, cross-chain applications, or games. But honestly, these are just suggestions. What we are really interested is in seeing what you come up with. Maybe it's something even we haven't thought of yet. That's the coolest thing about new tech, right? Sometimes the best ideas come from fresh perspectives or hackathons like ETHOnline. The qualification requirement for Starknet.anything bounty are pretty simple. The project source code must be hosted on a code repository like GitHub. The code must be your own work, and you must demonstrate that your project is executable on Starknet testnet and is working fine completely there. We are not expecting you to revolutionize the blockchain overnight. We are just curious to see what kind of creative solutions you can build using Starknet's features. So give it some thought. We are excited to see what you'll create. Remember, the goal isn't to make existing applications cheaper or migrating applications from different blockchains to Starknet. It's to imagine and build things that weren't possible before. So if you have any idea that you think could work very well on Starknet, we would love to see it. And don't worry about being perfect or world changing. We are here to help you for whatever need you have or whatever doubts you get. So, good luck and let's push the boundaries with Starknet.